Okay, so now we're going to talk about the right triangle, and we're going to talk about solving for a triangle. What do we mean by that? In solving a triangle, we're going to be given 3 parts of a triangle. Again, in a triangle, there are 6 parts. There are 3 angles and 3 sides. And so when we talk about solving a triangle, we're going to be given 3 of the parts. And at least one of those parts is a side, so we need at least one side. Now, and then we're going to use what we know to solve for the other 3 sides. So one of the things we're going to use is the fact that in a right triangle, we have a 90-degree angle. And so the other 2 angles must add up to 90 degrees. So that means the other 2 angles are going to be complementary. They have to be. Okay. The other thing too is we're also going to use we're going to use trig functions, and we've also got to use the angle that we're interested in is a reference angle. So a lot of the stuff that I've been saying when I say opposite over adjacent or opposite over hypotenuse and things like that is to kind of prime you for what we're doing now, because a lot of times you're going to be given a triangle like this where there's no XY axis and we're not dealing with a unit circle or anything like that. We're having an XY point and we got to figure out what the Y and X are, and we're using all that, which is fine. But in a case like this, there is no XY axis, so we just got angles and sides, right? So the idea of if I wanted to find alpha, or if I wanted to find this side and this side, I'm going to have to use trig functions, and then I have to use, well, what angle am I going to use? Am I going to use this angle or am I going to use this angle? Okay, that's going to be important. That's going to determine what trig function I use to find whatever side I'm looking for. Okay. What else can I say? I think that's it. So, okay, so looking at this one here, notice that we've got this alpha, we've got this angle alpha, this angle 35, so this means alpha, because these two have to add up to 90, because again, the interior angles of a triangle add up to 180, so since this is 90, these two have to add up to 90, which means alpha equals 55 degrees. Okay, now we're going to use the fact that of all of the similar triangles to this one, there's only one triangle that has a side where the length is 5 between 35 degree angle and a 90 degree angle. And so we're going to use that to solve these triangles. Okay? So again, when we look at sine of theta of an angle, we're talking about the opposite angle, or excuse me, the opposite side over the hypotenuse. When we talk about the cosine of an angle, we're talking about adjacent. The adjacent side over the hypotenuse. Okay? And then when we have tangent of theta, that's what? That's the opposite over adjacent, right? Those are the ratios. And then of course, if we have cosecant, oops, well, that's the reciprocal of sine, so that's going to be the hypotenuse over the opposite. And then if I have secant, which is the reciprocal of cosine, that's going to be the hypotenuse over the adjacent. And then, of course, cotangent of theta, which is the reciprocal of tangent theta, which is going to be adjacent over opposite. Okay? And so those are the ratios you're going to want to memorize. Okay? It's always the same thing. Okay? Now, some students use Sohcahtoa to remember these ratios. S-O-H, so, and then ka, right? C-O-C-A-H, so ka, and then toa, T-O-A. So again, some students use that to remember these three trigs, and then just remember that these are the reciprocals of these. Okay? Whatever you want to do, that's fine. Just memorize them. If you memorize them, life will become a lot easier for you when you're dealing with this stuff. Okay? So now, if I want to solve this triangle, well, I've already got the angle alpha. Now I just have to solve for these two sides. Okay? Well, I can relate these sides. So I got 5. So I could say, okay, I've got 35. Let's make that my theta. And I need the 5. So this is my adjacent angle. This is my reference angle. Then this is my adjacent angle. And I want to find, let's say this. Let's say I want to find this one. Let's call this B. And I want to find A. Well, what trig function relates the adjacent and the opposite? Well, that's going to be tangent, right? So tangent of 35 degrees, oops. So tangent of 35 degrees equals what? Opposite over adjacent. And so that means what? A equals 5 times tangent 35 degrees. And now I can just stick this in my calculator. And so I can do 5 times tangent 35. And that gives me 3.501. So that's, well, this is to the nearest degree, so I'm going to go to one significant digit, right? Is that what they do? So this would be approximately 4. So A is approximately 4. And then B, now I'm going to use this angle again, and let's say I want to relate the adjacent to the opposite. Well, that's going to be cosine. So I know that cosine of 35 degrees equals what? Adjacent over hypotenuse, which is going to be 5 over B, which then, if I solve for this, that's going to give me what? B equals 5 divided by the cosine of 35 degrees. So if I take 5 divided by cosine of 35, I get 6.10. So again, I'm going to go to one significant digit, or 1 degree. So that's going to be 6, or not 1 degree, this is, hold on. Hold on a second. This should be, we were doing 1 degree. So that would be 2 significant digits. So this should be 3.5. So 3.5. And this should be 6.1. Okay? And I've solved the triangle. That's it. So we'll do more next time. Have a good day.